It's a real pleasure to introduce Holly Andersen. I want to re-emphasize that the recent collection that she edited along with Sandy Mitchell is a really terrific introduction to the pragmatist turn in recent philosophy of science. And so she's joining us from Simon Fraser, and today she's going to talk about measuring modality.
All right, thank you. Okay, well, thank you for putting this together also. This work originally came out of discovering, I was talking to my former supervisor, Sandy Mitchell, I don't know, like 4 or 5 years after I'd graduated, that we both had this like secret interest in metaphysics, but you weren't allowed to say that word in HPS. And so we're like, oh, but you know, there's this pragmatism stuff, and it really seems like what we're doing is very pragmatist, and you could do a pragmatist metaphysics. And then we got really excited, and so fortunately also SFU has some funding sometimes for workshops, so we did a couple workshops, and that sort of in some weird way turned into the book collection. But it was really fun to go through that process of figuring out that it wasn't just that there were certain things about metaphysics that seemed completely antithetical to or unhelpful for philosophy of science, but that really what we were offering was some other way of doing metaphysics that we now just call pragmatist metaphysics. So I think there's been some progress in getting people over the sort of allergy to the word metaphysics in philosophy of science. I'll talk about that a bit more in here. I also have been doing a lot of work on this stuff lately, so I wanted to sort of situate what I'm going to be doing. Today I'm giving a talk that's sort of at the intersection of these two topics. But there's several other things that either are recently out or that are coming out soon that are there. And then I'm going to show how to do the kind of project that I think we should be doing here by doing a project. Whoops. Yeah, so there will be a talk within a talk here. So the within talk is about Lebesgue necessity, but I think that's also just a way of illustrating how we can do a certain kind of pragmatist metaphysical approach to how to balance sort of modal terms with measurement. So this also, I feel like I'm aiming this the wrong way. Or it's not working. There we go. Also fits in with some other work that I've done on foundations of causation and directionality and explanation. So those all kind of fit together, and I tried to extricate something that looked like one talk for this. I did discover that it's going to be kind of like big picture and hand wavy, so sort of taking the very synoptic view, to borrow Seller's phrase. So I do think that there's something that unifies all of this under the heading of pragmatist metaphysical methods. So that's kind of the orientation here. All right, so just for the outline, I'm going to do some background because I think it's helpful to kind of untangle some of the ways in which we've ended up in the contemporary discussion. I'm then going to look at a very recent account that's called Pragmatist, Account of Modality by Amy Thomason, and say what I think is maybe not going to work for that particular approach. I'm then going to say, okay, well, what would we be looking for from an account of modality if we were doing it with a sort of pragmatist approach? And I'm going to differentiate it from what I'm now calling post-Lewisian metaphysics. Because I think the term analytic has a lot of kind of laden things to it. And I think it's more like there's these two streams of discussion, and one of them is post-Lewisian and the other is kind of philosophy of science. All right. So the purple part is the talk within a talk. I'm going to convince you that there is good reason to think that there is this species of necessity called Lebesgue necessity. And I'm going to say kind of what it is, and also that I think it's the weakest version of necessity, but that it's not, as it's often called, a very high degree of probability. And then, of course, we have to ask, but is there really such a thing? And then we'll apply the pragmatist method to it, and that will give us some really interesting ways of understanding what it would mean to measure the existence of something like this. All right, so yeah, I feel like the previous two talks set me up really well for what I'm about to say, so that's great. And then finally, at the end, I'll return to the big picture synoptic view of things. Okay, so for the background, untangling these kind of three big strands in the historical trajectory. So I like to take a kind of longer historical lead up, and I do think that my orientation to pragmatism has been more Jamesian. So I was less influenced by Peirce, and I think I'm not as Deweyan as I could be. Nevertheless, it's really interesting to see that there's these caricatures of pragmatism that came out in especially the early 20th century. And the caricatures that I hear nowadays of like, oh, I would never be a pragmatist because, and then they cite these things that are the exact same caricatures. So I don't think we've actually moved that far in the last, century and a half. Another one of the issues that I'm going to push on, and so it was nice that Ken set this part up too. I think in philosophy of science, we've been a little too inclined towards rejecting or trying to avoid the word metaphysics, and then instead just thinking that we can do as well by being quietist about these issues. And I think this ends up leading us to do what I'm calling bump under the rug philosophizing, where you're like, well, I'm just solving my problem, and that bump goes over there, and now it's someone else's problem. So I think the synoptic view will make us be more responsible about bump rearranging. All right, and I'm going to sort of look at some of the post-Lewisian metaphysical starting assumptions that I think make it really untenable for this particular project about modality, but also just in general. All right, so getting a little more detail, some of the key criticisms that were launched against pragmatism in sort of the late 1800s and the early 1900s, a large part of it was concerned that it was deeply anti-realist and it was very disunified in its pluralism. Another concern is that it was language-oriented only, so that there was not enough, as it were, resistance from the world in what we were allowed to say was true or false. Instead, there was just more, we can just say whatever is useful or fine or makes us happy, and clearly that's not going to work in science, because the outcome of this might not make me happy, but nevertheless, I should think it's true. So I think that's untrue both historically and in the contemporary views. So rereading, I'm doing a pragmatist seminar with my students right now, and so I've just reread the Peirce and the James, and we have Dewey on next week. They're very explicit about being realist about things, and they're very explicit about real objects out there, real features of the world, and that we can't just wish the world would be a certain sort of way, and that's enough to make it true. And I also appreciate Peirce had an entire section on the study of useless things. I've heard a lot of people contemporarily, especially in like Humean pragmatists or pragmatist Humeans, saying that it's just human concerns and human orientation that we should be taking into account. But they take an idea where like human concerns have to be really like, I don't know, boringly adulty in a certain kind of way. Someone was like, well, I like to learn about dinosaurs, but that's useless. So, doesn't pragmatism tell me I don't get to learn about dinosaurs? And I was like, no, I don't know where you got that. You can learn about dinosaurs all you want. So Peirce actually has a whole section that I just discovered last week on the study of useless things, where he essentially says, look, if it's useful, somebody who can either get power or profit from it will study it. So what we need people doing science to study is all the useless stuff, all the stuff that doesn't just lead to some sort of profit. So I thought that was a nice addition. So these caricatures are often based on some presuppositions that I think should be rejected as false dichotomies. One of them really fits in with what Ken was talking about, that either there is one uniquely right set of joints in the world, and it's pretty sparse, there's not a lot of them, or you're anti-realist. So you either have to commit to this real sort of sparsity and uniqueness of description, or you're being an anti-realist. And I think the world can be dense with genuine structure, and there's no single best way to pick it out, but you still have an underlying sense of unity and realism. It's just not one where it's sparse or you have a single unique best description. So there wouldn't be anything that's fundamental, but there could be things that you might not ever be able to exhaust the structure of the world with description, and you're still allowed to be a realist. All right. The other is that modality, necessity, possibility, and actuality, impossibility, is built into the structure of the world, so something like a governing view of laws, or it's merely a feature of language and description. So I think this is also a false dichotomy that often comes up. And here I think Hasak Chang's book, Realism for Realistic People, has a very nice way of changing this, that people are concerned that pragmatism gives you something that's too mind-dependent. But mind-dependent really means something more like you can make the world be the way you want it to, and we don't get to do that. We just get to frame it. And so he's highlighting the fact that you never have a language-free way of talking about the world. No matter what you're saying it in some language. So that's all the more you have to do. So that gets you around this sort of false dichotomy. All right. So these caricatures of pragmatism and lots of other stuff that I'm just going to wave my hands at, lots of sociological factors in the 20th century, I think led philosophers of science going to logical empiricism and its descendants for their sort of verificationist needs. Because people like Russell got us really spooked about necessary connections and the principle of the principle of sufficient reason. And then we also sort of inherited this allergy from, I don't know, Otto Neurath and others to the word metaphysics itself. So there's a paper by Nancy Cartwright, From Causation to Explanation and Back Again, in which she sort of traces this, causation came to have a bad name, so instead we tried to avoid any talk of it because it was modally problematic, and instead we went to explanation and tried to do everything with explanation and probability, and eventually discovered that it just wasn't ever going to work. There just wasn't enough there, and we had to go back to causation again, in, of course, a new form. And so the treatment of modality, especially necessity and possibility, in philosophy of science through the 20th century, I think really was one where we tried to offload understandings of necessity onto logical structure, so that instead of talking about necessity, we just were doing logical derivations. We also then sort of offloaded possibility and actuality into probability and tried to run with that as much as we could. All right. And it didn't really work. But then we introduced it back as grudgingly as possible. So we did discover that we need this, some sort of a binary between, or some sort of a distinction between necessity and contingency for different ways of formulating laws. But we still brought back only just a kind of binary version of it. So Sandy Mitchell has a criticism of this in one of her early papers. We brought back a little bit of sort of oomphiness, but we're now doing it in a sort of the context of well-defined manipulations in causation. And sometimes we try and lump these all together. So we talk about counterfactual variation for explanation, so people like Alex Breitlinger, or we try to lump together causal and mathematical explanations, etc. We'll get more into that. And I found a lot of people that I'm trying to convince to get on board with the it's okay to do metaphysics because you're already doing metaphysics, are like, well, what if I just avoid the word metaphysics? I think that what ends up happening, well, we'll talk about this more. A lot of people are concerned not about metaphysics, but about specifically post-Lewisian metaphysics. And in that sense, we're also recreating what the pragmatists were doing, who were really known for criticizing metaphysics. But what they meant by metaphysics was the sort of neo-Hegelian absolute that they were talking about. So they were also pretty clear that they didn't like metaphysics done this way, but they thought that we should do it this other way instead. All right. Oh yeah, and, oops. Did I just, oh yeah, there we go. So here's our Peirce quote: find a scientific person who proposes to get along without any metaphysics, and you found one whose doctrines are thoroughly vitiated by the crude and unexamined, is what that should say, metaphysics with which they are packed. Every one of us has a metaphysics and has to have one. It will influence their life greatly. Far better then that metaphysics should be criticized and not be allowed to run loose. So you should keep it in view, and you should evaluate it, and you should make sure that you're on board with the things that you're committing to. So examples of this, I think in the metaphysics, I was surprised in some of the mechanisms discussions. There was at least one person who's like, I just don't say the word causation, and then I'm fine. But was still making very laden causal claims about lots of other stuff, just not using the word causation. And I also, in the Truing paper, that is the chapter in the collected volume with Sandy, I think there's a lot of people who are like, well, I don't need a theory of truth and I don't want to do any of this epistemology stuff. But I am going to make this really sweeping claim that all idealizations in models are false. And so now we have to figure out how they can explain so well, given that they're all false. And it's like, well, but you are using a theory of truth in there. It's just not a good one. And you could do a better job. And, So in that sense, I think that the philosophers of science who are being quietist about this still end up doing both the epistemology and the metaphysics under the table. And it is better to sort of bring it out and kind of integrate it. All right, and that brings us to the bump under the rug philosophizing, where you solve your problem right here in, I don't know, well, I work in a lot of stuff related to explanation. So you solve your problem right here with explanation by moving that part over to understanding, which obviously is going to be easier to solve because you're like looking at it from a distance and squinting really hard because you're so busy working on your topic right here. So you're moving it around. And so I think thinking of this in a sort of metaphysical sense means you have to think about this sort of underlying unity to how things hang together, not in the sense of having there be some firm foundation, but that they all have to sort of integrate in this coherentist way. So you have to at least periodically sort of put your head up and take the, the synoptic view to make sure you're not doing that. All right. Oh yeah, this is the pot of final science at the end of the rainbow. So one of the reasons that post-Lewisian metaphysics has really not been helpful for philosophy of science, and this also is something that Ken mentioned, they have deeply unrealistic expectations for science. So they have this idea that like, well, current science is going to change, but there'll be final science, and what I'm talking about is final science. And then there is this idea that someday it'll just be over, like we'll just finish and now we're done and that's the end of science. And William James, I think, has some nicer things to say about, science as this ongoing process. Whoops, there was one more I'm missing there. All right. There's also this sort of trivialized notion of possibility that doesn't do what philosophers of science need it to do. So even if you're not a realist about possible worlds, there's something about possible world semantics that doesn't fit onto the kinds of claims that we want to be able to evaluate counterfactually. And I think that Peirce has this distinction between positive possibility and sort of other notions of possibility, and that's not something that you can really mark in even an ersatzist approach to possible world semantics. So he wants to say there's something about the acorn where it can, the acorn can possibly grow into an oak tree, whereas the pine cone cannot grow into a pine tree in the same kind of way. There's a fundamental difference in the type of possibility there, whereas in possible world semantics, that's sort of flattened, and then you just get things at different distances, but it's still the same notion of possibility. So I think that philosophers of science have been looking for something more like Peirce's notion of positive possibility. It also requires a commitment to the Humean mosaic, which I think is really huge, that there's just no constraint or differentiation on how things could have been in this world. You could just like randomly throw up all the pieces and they could go wherever they go and that's it. And I think pragmatist approaches in Humeanism just aren't pragmatist enough. Yeah, I'll leave that there. Okay. So I think that a lot of philosophers of science have drawn on logical empiricism for something that they'd be better off getting from pragmatism. And I think part of why that is because in the logical empiricist version, it's a much narrower and more atomistic approach to what counts as making a difference to experience. So you measure things much more one at a time, sort of in separation from their sort of modeling context. And you also have a very direct understanding of what counts as making a difference to experience. So if you look at William James, he has a much more inclusive understanding of what counts as making a difference to experience. Okay, and then we can avoid the bump in the rug, we can do better metaphysics, but that then brings us to the question for the next section. I think that we can do useful things with modal distinctions. So I think that it's time for philosophers of science to really start thinking more specifically about what we're doing when we talk about things that are actual and were sort of necessary, or things that were necessary to different degrees. So Mark Lang has a distinction between phenomenological laws and meta laws that could constrain how those laws are, but actually that distinction goes all the way back to Wigner. So there's a lot of room in physics for that sort of distinction that doesn't show up already. All right, so if we were to taxonomize modality, what kind of things do we need to put in there? So one of the, something that I just became aware of is this paper by Amy Thomason on a neo-pragmatist approach to modality. And I apologize to her because I'm going to not give you as much detail as you would need to know why I disagree with this, but I'm just going to tell you that I disagree with it. She's coming very much from the post-Lewisian tradition, and she wants to start by identifying what is the function of any linguistic discourse. such that we could then figure out what is the function of modal discourse, such that we could then go on and figure out these other sorts of things. So there's a real kind of, you start with like, what does it mean to use a discourse for anything in the first place? And then you kind of narrow your way down to answer the question for modality. And I think this is a really, I don't know, generally my intuitions go much more bottom up, but I think there is something problematic about going this heavily handed top down, because you have to think that there exist sort of well-defined functions of linguistic discourse, and then you have to hold that there's one or multiple well-defined determinate functions of modal discourse. And there's something very static and kind of prescriptivist about this. So one of the things that's really interesting, I think, in linguistics is that we just keep changing how we're using things in new ways, and we come up with new functions for them. And there is no, I think, well-defined range of what you can do with a discourse or what you can do with modal terminology. So going top down, you have to solve this huge problem just to get to this small thing. And I think you just have to like take on less philosophical baggage if you go kind of bottom up. I also think it's really hard to apply in formal languages. So this is actually connected to Jim's question too. I don't know what you would say about the function of the discourse that is using differential calculus to solve certain kinds of problems, or what is the function of graph theory? I don't even know how you would answer that. All right, so instead, well, how's this? I think we can compare this with certain kinds of tool use. So some tools do in fact have a really clearly defined function. So things like hammers and screwdrivers and saws were literally designed to do certain functions for us. But when you ask the question in the form, what is the function of a hammer, it leads to a certain kind of what's called rigidity about tool use. So they actually test kids on this. You can get out, there's like a cognitive scale of development of becoming more flexible about tool use. Sometimes you're in a room and really what you have to do is tie the string around the hammer and then use it to swing as a pendulum over there. And you're not going to come, that's definitely not the function of a hammer, but you should be able to use the hammer that way when circumstances call for it. So I think this happens all the time with really interesting things in the sciences. So I think the uses to which the Navier-Stokes equations get put, or the Lotka-Volterra equations in biology, well, not even in biology only anymore, vastly outstrip what they were originally for. So what is it for will give you a narrower view, whereas if this is my problem over here, what is the best available tool for the job, will give you a very different range of answers. So there's concerns about realism, for example, where sciences might not be in the business of providing realist descriptions of the world. At the same time, if you personally are interested in having well-founded realist beliefs about the world, science is still your best tool for that job. All right, so instead we could start from this other way of phrasing it. So if you ask what is the function of X modal discourse, it might lead to a range of answers that isn't wrong, but it is too narrow. What could we use X for might return a much broader answer. And then what tool is best suited to solve this problem, where you have a more specific understanding of your problem, instead focuses this broad range down again usefully, but you'll notice it's outside of the original function of that tool. So that's why I think the discourse thing is not going to be as helpful. So what are we trying to solve when distinctively modal terms seem like the best tool for this job? So part of it is just identifying the types of necessity and possibility that play key roles in various scientific settings. And then what's appropriate to the job will really depend on the exact nature of what you're talking about. So on the one hand, you shouldn't be proliferating distinctions needlessly, of course. But what the pragmatist metaphysics, I think, should do is kind of see which ones pay off investment. So there might be a lot more that are sort of worth their weight in terms of the inferences or the specificity of claims that you're then able to make with it. So you can be a small r realist instead of like a big R realist about it. And I don't think we should avoid distinctions just to have fewer of them. So I do think this is what post-Lewisian metaphysics is doing. As few terms as you can get away with is better. And I think that we should just aim at something different in this other strand of pragmatist metaphysics. So there's lots of unificatory possibilities. There's lots of things about translation. Sometimes you can do more with more. All right. So here I'm just gonna, summarize this a little bit. There's a couple people who tried to bring together causation and grounding and like, oh, we can cover them with one account. So I was having a discussion with Al Wilson about this that is now in this paper right here. And he thought it was really great because you could then have just one relation in the world, and then you could just have one instead of two, which seemed obviously better. But the problem is that when you do that, you have to give up the causal Markov condition, which means that you've now given up the single thing that you need to be able to make any inferences whatsoever about causal structure. The entire thing that makes it worth doing causal modeling is that you can make these awesome inferences when you find certain examples of causal relationships. You just have to give it all up. You lose the whole thing if you try and put grounding together with it. And it's well, maybe we shouldn't do that. Maybe we should just have two that are defined in more narrow ways. But then when you find an instance of each one, you can make stronger inferences as a result. So I think that's more the emphasis of the pragmatist metaphysics. This also comes out, I think we should distinguish mathematical from causal explanation, also by the strength of connection in the explanation, because we should keep the definition of causal explanation really narrow. We don't want every explanation to just count as causal, because then it no longer means anything to say that you found a causal explanation. All right, and I also just came across this paper by Rient and Guy, who are identifying different kinds of possibilities in Lagrangian mechanics between kinematical and dynamical possibilities. And actually it's really interesting. And by making this distinction about two different ways of being possible in that setting, you really come to understand how things work in there better. So I thought it was very illuminating. So just a general taxonomic principle, I think modality should track similarity in behavior. So patterns of counterfactual variation, inferences supported, etc. And it should, in some sense, make a difference to experience or be verifiable on this pragmatist understanding. Okay. So now I'm going to argue for this thing called Lebesgue necessity. It should be pretty straightforward, so I apologize if you are not that familiar, even passingly, with thermodynamics and statistical mechanics. I tried to make it a little more easy if you are not. So the motivation is just that there's sometimes spaces where it's a continuous volume, and one outcome is measure one on the space, but there's at least some points in the space that are of a different outcome, so a measure zero outcome. So one example is if you have a continuous volume, let's say, and then the irrational numbers are one outcome, and then the other one is the rational numbers. And so there's a way in which one of them is measure zero, but it still has points in this space. So these come up in different, say, phase space representations for thermodynamic behavior. It comes up, I think, in Norton's dome example for Newtonian mechanics. So then it's not a countable infinity of exceptions. There might only be one point, but it's still one rather than zero. So you have this sort of change in the structure. All right. So then Lebesgue necessity is just to say, for any possibility space with at least one continuously valued dimension, where some outcome A has measure one on the space and some non-empty complement A prime has measure zero on that space, then A is Lebesgue necessary on that space, and A prime is merely Lebesgue possible on that space. So you just sort of call it that. All right, so some features to note about it. I think that Lebesgue necessity is stronger than very high probability. And I realized this paper kind of came out of an argument that I was having with my MA supervisor a very long time ago, where he's like, no, it's just very, very high probability. And I was like, it doesn't feel like it behaves like it. It behaves much more like necessity, but slightly weaker than we were expecting. It does not behave like high probability. And I also think it's weaker than what we call nomological necessity. So that associated with deterministic laws, because they would have no measure zero exceptions. So what I'm essentially saying is that if we have an otherwise deterministic system, such as Newtonian mechanics, and then there is at least one measure zero outcome point, then we don't have to flip the whole thing over to probability and say it's very, very highly probable. Instead, we can just say it's a slightly weaker species of necessity. So we're just sort of clustering it over here instead. Okay. And it would be the weakest species of necessity because it requires this cardinality difference equivalent to the difference between the uncountably infinite and the countably infinite. You can't do it on discrete spaces, essentially. This will turn out to be really relevant later on. Okay. And it is a feature of the space, not a feature of how the outcome is selected from the space. And I've given this talk a couple times, and people, especially from the post-Lewisian metaphysics tradition, are just but then Lebesgue impossible things can happen. And it's like, yes, that is in fact a consequence of this. Depending on how you select your outcome from the space, that might actually happen. So the probability of getting the measure 1, measure 0 outcomes will depend on how you're selecting from the space. So it's a feature of the space itself. And it's related to, and here I thank Sheeman and her philosophy of science reading group for helping with this. It's related to, but not the same as, discussions around typicality or naturalness. And there's a discussion that you pointed out about pointlessness in quantum mechanics. And it's sort of different, but it's closely connected to all of those. So I'm just going to wave my hands at that. We can talk about it later. And also, it's a really well-known behavior. I'm not saying anything new with that. I'm just changing how we label it. Instead of calling it like vanishingly low probability of getting some of those outcomes, I'm like, no, it's merely Lebesgue possible. And the other ones aren't merely very highly probable. They are, in fact, Lebesgue necessary. Okay. So then you might think, well, is there even such a thing? Because the reason a lot of people haven't done this is they were very concerned that it was an artifact of the representational space. So you might ask, is there really such a thing out there in the world? Or should we try and not interpret that particular part of our representations? And I think this is a false dichotomy in two ways. One, because it's going to end up relying on a certain kind of atomism about measurement and verification. And it presupposes that something's either out there in the world or just in the representation, but not, here I'll just bring back the Chang stuff about how you never just have one or the other. You only ever have using the representation to talk about the world. Okay, so what's at stake if we applied the pragmatist method here? There's two further commitments that I think the pragmatist should make about measurement. One is that we always have non-zero noise or error for any measurement. So for any measurement, because of the physicality of measurement, there is no such thing as a genuinely error-free measurement process. And I take this one to be pretty low stakes, but you can disagree with me if you want to. The other one is that we always have a finite number of significant digits for any measurement, or there's no such thing as a measurement with an infinite number of significant digits. And you have to be really careful, and I had to take a whole class, half of which was learning how to figure out how many significant digits you had, and then also how not to accidentally lose them or add them, because you didn't want to add spurious precision, but you also didn't want to lose some of the precision that you had. So that's something that philosophers of science haven't paid a lot of attention to, but it plays a big role when you're learning how to do measurement. So I think we can improve noise levels and significant digits over time, but even in the idealized long run, you're just never going to get to the ideal version. Okay. So then you have this really interesting, what would it mean to measure a system to confirm that it has Lebesgue necessity? One problem that you might run into is that you're only ever going to find the measure 1 outcomes. So because you will always have some amount of error and noise, you're always going to have a case where the base rate occurrence of measurements that are noisy or in error is going to be higher than what you're expecting for the measure 0 outcomes. And so you're never going, even if you take a measurement that looks like it's confirming the measure 0 outcome occurred, it's more likely to be an error than it was to be an actual measurement. So this issue means that we can't use these measurement processes to reliably distinguish Lebesgue necessity from nomological necessity. So it's only ever going to return the measure 1 outcome. On the other hand, the measurement of systems potentially displaying Lebesgue necessity might not only, but largely or disproportionately identify measure 0 outcomes. So the finitude of the significant digits for any measurement means that you're always going to get something that, if you're not careful enough, looks like what you have is a very determinant number, and you want to make sure that you don't add zeros in your head at the end of whatever significant digits that you have. So when you put a measurement into this possibility space, what it does is pick out a small volume of points. It doesn't pick out a point. And depending then on how you're registering this, it might look like let's say you're using the original sort of toy example I gave you of irrational numbers and rational numbers. It might look disproportionately like you're always measuring rational numbers, even though they're measure 0 on the space. So it depends on how they're mapped into the space and how you're selecting from it. But this means that you can't use measurement processes to reliably distinguish Lebesgue necessity from high probability. So you've got the other kind of problem right there. All right, that was very text dense, so then I just put in a tree so we could. take a break. All right, that was on Burnaby Mountain. So I think that these issues coming together highlight this problem about thinking in an insufficiently pragmatist way about how modality could be measured. We can't approach it with this sort of atomistic, direct measurement approach. So the sheer physicality of measurements in this really broad way means that there's always going to be some small but ineliminable mathematical free play in how you get the outcomes of your measurements to constrain your mathematical systems. And that's exactly in that free play is exactly where Lebesgue necessity sits. So the measurements are never going to rule it out, but they're also never going to rule it in. So what do we do? Okay, well, if you're really uncomfortable about this, then you could disallow the use of any space where you're going to have this non-empty measure zero outcome, where you try to remove your little point discontinuities. And then here there's also a really interesting paper that just came out by Bennett and Miller, The Conventionality of Real Valued Variables. So they're doing work in the formal justification for representational theory of measurement, so how you get the numbers of your measurement to line up with the representational space. And they concluded that, in fact, we're actually justified in using Q, the rational numbers, but not R, the real numbers. So the current justificatory status of the real numbers being used outstrips somewhat what we have from the representational theory of measurement. All right. So you could do this really extreme move where you're going to eliminate any mathematical representation that allows for Lebesgue necessity, or you could stick strictly to your justification guns and only use the rational numbers and not the real numbers. But what you have now given up is using anything that's like continuously integratable or differentiable in order to do so. So you could hold to this really super high ideal, and it would be extraordinarily costly. Okay, so what I want to point out is that there's two whole packages here, and what the measurement process sort of yielded is that we have to choose one of these two packages, but that we're not necessitated in choosing one or the other. So package one, we can sort of keep using calculus and real numbers, and we can accept that this means that there's possibly systems that exhibit Lebesgue necessity. Or we could avoid Lebesgue necessity and have stricter adherence to the justification for representational theory of measurement. But now we've given up the use of real valued quantities and probably more, and thus we can't even use calculus in the way that we're currently using it. So the measurements don't determine which of these two things we have to do, because the difference in that comes right in that sort of free play of physical measurement that I was talking about. So conveniently, because we can choose the one that doesn't stink quite so much. I don't think that we should choose to give up calculus. But this has a really interesting implication. So it means that we're now just sort of on board with the idea that there might be systems in the world that exhibit Lebesgue necessity, but also it means that there's a kind of metaphysical commitment to the world just involved in using calculus. So you're already committing to things just by choosing those sort of mathematical techniques that we generally tend to think of as uninterpreted or pre-interpreted or not having direct physical significance. Instead, it's part of a package, and that whole package is verified together with measurement. And that means that we have to sort of choose those two packages, and it doesn't just sort of come in this completely a priori way. Okay. So yeah, for it to be true that there is Lebesgue necessity is for this idea that we choose this package to make itself useful in getting around an experience in this broader possible way. Yeah, which I think we should do. Okay, interestingly, while I was doing the, I don't know, I've given just the shorter version of this talk a couple times, and then I was reading Peirce last week, and I actually think Peirce made this argument. And that was really surprising because I hadn't read enough Peirce apparently. So he has this doctrine of fallibilism. On the whole, then, we cannot in any way reach perfect certitude nor exactitude. We can never be absolutely sure of anything, nor can we, with any probability, ascertain the exact value of any measure or general ratio. So he thinks that, in some sense, you should never be absolutely certain something's going to happen or is necessary or that it's impossible. So you should always be somewhere in between. And I think his use of perfect certitude and exactitude is exactly those two measurement issues that I just picked out. He says, but in order to see all there is in the doctrine of fallibilism, it's necessary to introduce the idea of continuity or unbrokenness. This is the leading idea of differential calculus and of all the useful branches of mathematics. He goes on to say some stuff about infinity, and he's like, continuity involves infinity in the strictest sense, and infinity, even in a less strict sense, goes beyond the possibility of direct experience. And he concludes that we should still choose continuity anyways, because you don't have to either choose it or give it up. So you've sort of reached this kind of like existential lack of foundation that goes with the pragmatist. And it's like, you either choose continuity or not, but there's nothing in your experience that can, as it were, necessitate it or tell against it. But it's easier to reason about continuity than about discontinuity. So it is a convenient assumption. So this is one of the main reasons that he gives in favor of why we should assume that the things that we're measuring in the sciences are continuous. All right. So the general, approach here, I'm trying to offer just like some, metaphysical methodological considerations that emphasizes the usefulness of some of these modal distinctions rather than trying to be more sparse about our modal distinctions. So when we use narrower or more restrictive definitions for things like causation versus, say, mathematical explanation or causation versus grounding, then we thereby also, when we find instances of those relations, have much stronger inferences that we can make about them. So avoiding needless proliferation of distinctions is always a good thing, but a well-carved set of distinctions is a very useful tool, and we should not avoid it just for the sake of sort of metaphysical austerity. So we're not on a, relation diet. So we then had also the taxonomization principle for modality, where it's helpful to see how they behave and then cluster them in similar sorts of ways. So I think there's interestingly more species of necessity that we could probably articulate. I think there's something to the bottom-up flexibility, so that instead of asking, what is the function of modal discourse, for example, or of this modal distinction, we can rephrase it to, what is the problem at hand that we're trying to solve, and which of these tools are the best solution for that particular job? And then we may end up reusing something that was not originally for that, but that nevertheless ends up being the best tool for that particular job. Yeah, there's just the reminder of the taxonomic principle and the pragmatist methodology for modality. And a reminder that James, I'm taking this from James, and he was a psychologist, and so you can actually get a lot of information about what he meant by experience and making a difference to experience by reading the first version of the Principles of Psychology. Like, he really gives it to you there, and it's very explicitly holist. So he thinks that experience comes in this big whole, and then later on you can analyze it into components, but it doesn't come in little components. So it's almost the inverse of what you get from like the logical empiricists or like little sense data, like little Legos that you sort of build up into something. He goes the opposite direction. And so making a difference to experience is this much richer, sort of longer term thing for him. All right. And so the physicality of measurements, I think, has direct consequences for what we think of as direct verification. We will never be able to ultimately directly verify all sorts of different things, but that doesn't mean that anything goes, that we can make up any kind of representational systems that we want. But it does mean that there's no one uniquely correct right answer. And the way in which we have to sort of use our measurements to check whether we're justified involves this kind of holistic package. So there is no, as it were, metaphysics-free mathematical structure where only some, I think, mathematics is physically interpreted. If you're already committed to things about the world that are slightly outstripping direct experience by using things like continuously valued variables. But I think this is a useful tension, and that's why we have the picture of the bridge. Because I'm also the kind of pragmatist who thinks, there is in fact some underlying unity, and I am in fact an optimistic realist at heart, but I don't have to have like a foundation on which everything else then rests to provide that underlying unity. So I think these things sort of hold each other in fruitful tension such that you get the coherence that you're looking for in the package. So I think that this kind of tension where in one hand, the modality seems the least connected directly to experience when you say that something's possible but not actual. You can't measure that. And measurements seem the most directly connected, but they're still sort of pulling the whole system into the right kind of shape when you use it like that. And then, of course, just as a small note, I really do think we should talk about Lebesgue necessity. I don't think we should talk about this, like the occurrence of anti-thermodynamic behavior as like vanishingly unlikely. I think it should be like Lebesgue impossible or merely Lebesgue possible. So I think that this turns up surprisingly often, and then putting it into the necessity camp instead of the probability camp just makes those discussions simpler. And yeah, that's it.
Okay, so I have a ton of questions. So I saw Hugh first, and then I'll try to get everyone else on the list. Yeah, great. Go ahead, Hugh.
Thank you, Holly. That was fascinating and almost completely convincing. Just one thing I want to push back on a bit on behalf of Amy Thomason. I think the gap between your view and Amy's is less than you think. And two reasons for that. One is that one of the things that Amy is very interested in, especially in her recent work, is the notion of conceptual engineering, in a sense, which goes right back to Kant. So it's really the question, how do we choose our linguistic frameworks? And as in Kant, it's a pragmatic question. So it's a sort of framework which fits very nicely with the kind of approach that you're taking to it, in this case, modality and necessity. But certainly, and this is even more novel in Amy's work, her new book, which is coming out, I think, late this year or early next year, is called Rethinking Metaphysics. And one of the things she means by the title is conceptual engineering applied to the notion of metaphysics itself. In other words, how should we as pragmatists think of metaphysics? And that seems, thoroughly compatible with your, not only with your project, but with things other people, Ken's talk, for example.
Yeah. So I agree. I think, so in some sense, I think that my concerns were more the direction she took to get to a view, being more top-down rather than mine being more bottom-up. And I agree that I think they come to a much more similar place in the middle. And there was a section in here that was actually much longer, and that also involved your work in the distinction between E and I representations. And it was like 20 minutes, and I had to take it out. So I think you're right, there's much more to be said about that. I think I'm looking forward to the book when it comes out. I want to sort of be cautious. So there's what people want to get out of Carnap, and then there's what's in Carnap, and I worry that they're not the same thing. And so I get worried when people put Carnap as a pragmatist, because then I think you have to be really super careful, because it's not totally false, but it's also not straightforwardly true or true for all the things he says. And I think the central differences come down to what counts as verification of these linguistic frameworks, how airtight or logically prescribed do the linguistic frameworks have to be, and things like this. So in that sense, I feel like I don't disagree, but I would want to add little caveats about the Carnapian pragmatist stuff.
Okay, just on the top-down versus bottom-up thing. I mean, one difference that's worth having on the table is that in some cases we approach these questions by looking at notions that we find in folk use. In wider creatures like us have those sorts of concepts. And that, in a sense, is naturally top-down because we're coming from what we already have. Whereas once we become conceptual engineers, then it's naturally bottom-up. But there isn't really a tension between those two.
Yeah, I agree. So I've seen some other people be a little more prescriptivist about language when you talk about the function of different kinds of linguistic terms or linguistic discourses. And I agree that you don't have to be in order to do that sort of thing. And that what's really interesting about it is the way in which it can get redeployed in these other fashions, which I think conceptual engineering is such a redeployment with a sort of more self-aware orientation to it. So yeah, there's more to yeah, well.
Okay, Doreen is next on my list.
All right, thank you, Holly, especially for the great pictures. So I liked the way you started by thinking of mathematics as a tool, and the example of swinging the hammer versus using it in the straightforward way. One of the things I worried about as you went through the Lebesgue example was how much you were taking your conclusions from thinking in entirely abstract terms about that piece of mathematics and where exactly the physical interpretation of it was coming in. So I'm wondering whether you think there are ever any cases in which the physical interpretation you give to the Lebesgue kind of situation could be reasonably interpreted in terms of probability, or if you think that if your conclusions are more specifically tied to the kinds of statistical mechanics cases you had in the background.
Sort of. Here's where I tried not to go into the really noodly details of the statistical mechanics and thermodynamics stuff, because I thought not everybody in the room would be as interested in it. So I think there's different ways of representing it in those particular cases where you might want to say there is or not. And I think that sometimes there would be something that was also very vague, sorry. I think that you can have different ways of dealing with phase space representations that put you on one path where you end up sort of committing to Lebesgue necessity or not. And so in some sense, I want to make the more modest claim that you ought not rule that out in advance, even though sometimes it may end up turning out that it is an artifact in these particular cases, or that you can avoid it and you have reason to avoid it. So I want to say that just its existing isn't reason to avoid it alone, and that it's a possibility, not that it always happens. Is that sort of?
So sometimes you're going to get to probabilistic
Yes.
interpretations, and sometimes you're not.
Yes.
Okay, good.
On more details, yes.
Okay, so I had John and then Wayne and then Jack. So why don't we go to John?
Thank you. This was awesome. And I like all the parts of it. I want to ask a question about the historical part at the beginning. So I found it very illuminating. At the end of it, you said that, look, analytic metaphysicians are doing these things and they shouldn't be doing them, but they have some reasons to do it. For example, they're waiting for the end of science, whatever. That's a silly thing to do. Because James told us, of course, the conversation will continue. But like my vulgar understanding of Peirce is that he said, the end of science is going to play an important role in our understanding of truth, for example. And like pragmatist people like Sellers also use this sort of like, there's some sort of notion of end of science that plays a role. And so is this just, I don't know my Peirce well enough?
You might know Peirce better than me, because I'm much more familiar with James than Peirce. So I'm not sure, and I think Peirce changes somewhat on, like, depending on when he was writing on this. So from a historical perspective, at least the part that we were reading in seminar last term talked about science as this ongoing process, and it's not a static body of anything, and it's not any finished product. It just is this ongoing process, and in that sense he really seemed to think it wasn't going to be over in any straightforward sense. So for that, I think there might be other and actually Elisa is the more she knows a lot more of the Peirce. Okay, but I don't think James thinks that we're ever going to reach the end of it either, and he's pretty explicit about this, because he's like, look, it's taking account of experience, and the very fact that we have these new distinctions allow us to get new experiences. So in some sense, once you have more distinctions that help you build this new kind of equipment, and then you make this new sort of observation that you haven't been able to make before, then you have this ongoing addition to experience that you have to take into account. So for James, the end of science would be like literally apocalyptic, like all the people die, and that's it. And then, okay, we're done. That was wherever we stopped, was where we stopped. I'm a big fan of like Paul Dirac and Wigner, and I think Wigner actually has some really interesting stuff about why you should be really super skeptical, even if you think you got to the end of science. Chances are you're probably wrong. So I think I think he takes a more pragmatist approach to it there as well, even though he wasn't explicitly pragmatist.
Wayne, go ahead.
Thanks for this. It's very interesting, and it actually connects with some things I've spent time thinking about. So I want to talk about this more. Just a terminological issue. Is this phrase "best possibility," the necessity, is that yours, or is it something that's out there that other people are using?
This is mine.
So the reason I ask is in statistical mechanical literature, people very often talk about typicality, and the idea is that you've got some physically salient measure, and you want to you say behavior is typical if it has measure 1, and that's not tied to any particular measure.
Mm-hmm.
And I would suggest terminology it's not tied to any particular measure, because what you're really interested in the phenomena that on some measure spaces they're non-empty sets with 0 measure.
Mm-hmm.
And you might want to have something like a Haas measure or something like that, which is not a Lebesgue measure. And also, it raises the question, if you put it that way, if you have to talk about some physically salient measure, it raises the interesting question of which measure are the physical salient ones.
Yeah.
Okay, so, and it can make a difference. So, if you have to take a set of points online, there's all kinds of measures that I can put on that, which will differ in which your things are sets of measure zero. And something that came as a surprise to me is that you can have a continuous one-one mapping of a line that takes sets of measure zero into sets that are not measure zero.
Okay, I hadn't seen that part. I haven't. Yeah.
And so you can find a new measure by this mapping. And the interesting thing is that you can't have smooth mappings.
Mm-hmm.
It's continuous but not smooth.
Yeah.
And so if I'm picking out one particular measure as the right one to do measure zero, I'm not just using the topological structure of the space. I'm using its differential structure, which things are smooth mappings and which aren't. And I think that that's actually the interesting fact.
Yeah. This is true. I also took out, there was a longer discussion of how it related to typicality that didn't make the time cut. So we should talk about it more because I haven't heard of the one, some of the stuff that you were talking about the mapping it to measure one space. Yeah.
And Jack, could you come forward to use one of the mics?
Sure.
Oh, you've got a mic.
Quick.
Great.
Thank you very much. I enjoyed the talk very much. This question is very similar to points already raised by Wayne and Doreen, but you distinguished this notion of Lebesgue necessary from simply like very high probability. But in the context which I believe you have in mind, it would be identified with probability 1 rather than just very high probability. So I was wondering, because when stated that way, obviously probability 1 is already a quite, in a way, metaphysically extreme position to be in. So I was wondering to what extent you consider this particular species of necessity as sort of the same thing as just total certainty, at least within these kinds of contexts.
Yeah, so that's a really good question. And actually, I used to present this when I was doing it with Schumann's group. It was introduced using the concept of probability and how we usually use it to stitch between probability equals 0 and then probability equals 1. But we have these interesting ambiguities around probability equals 1, where many things get chucked in there that have very different behaviors. And so when I'm looking at things where, okay, so where does, say, causal modeling, when you've got a causal relationship, I think that we should distinguish it from more like deterministic laws, because I think they behave differently, because you can't intervene on these, even in principle, in the way that you would need to intervene on these things right here. And so I think we're better off kind of keeping them separate, but you've got this problem right there, the probability equals 1. So mostly, I think there's a lot of interesting stuff that happens right at that juncture. And I'm still in the process of figuring out how we should, what I want to say about how to treat that. Because there's a lot of things that come in there, not just Lebesgue necessity.
Okay, thank you very much.
Thanks.
Thanks. I think I can say with very high probability of being correct that lunch is served. So
Okay.
join me in thanking Holly for the time.
Thank you.